Hello dear friends, welcome to Gate Academy Global. So before starting today's session, let me ask one thing, the quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the live chat. The agenda behind today's video is very precise and clear. We are going to discuss the 12 different kinds of the problems which have come in the previous year GATE examination based on the concept of state space analysis. So I have taken almost all varieties of the problem within the SSA which can be fabricated. So the 12 number of problem I am going to take in today's session. So here goes my first problem. You can see very well here the system has been represented by its signal flow graph, and I need to get the matrix A, B, C or D, or you can say the given signal flow graph has to be converted into form of signal SSM. That would be my first problem. And keep in mind, the first problem was a linked problem. With the help of the first output, even we had to get the state transmission matrix, and I have seen repeatedly the problem do come over this concept where I need to calculate the state transition matrix for the given SSM. And once this problem is getting over, I would be taking the next problem, which is nothing but the third problem. Again, the signal flow graph for a certain system has been given to you, and with the help of this signal flow graph, again you had to get the SSM. That's nothing but the state space model for the given system. And it was also a linked problem. So what we had to do, once the SSM is known to me for the given SFG, I need to get the transfer function for the given system. And the derivation for getting the transfer function is already been calculated in the last video. The person who is having any sort of doubt can refer my last video. Yes, this would be my fourth problem. Once the 4 number of problem is getting over, I would move into the fifth problem, and this problem is based on the concept of zero input response. What does that mean of it? If you'll recall the first equation, which was a governing equation within the SSM, that was nothing but the state equation, which was x dot is equals to of ax plus of bu. This is the specialized case where I do not have any physical input, and I need to get the worth of the state variables with respect to the time. This would be the next question. And once this problem is getting over, I would move into the next question. And again the problem is more or less same as we have seen earlier. It's a case of homogeneous state equation. What does that mean of it? When we call a differential equation as a homogeneous differential equation, that we have studied as a part of engineering mathematics, when the input is specifically 0. And again this is the case where the first equation, which is nothing but the state equation, which used to be x dot is equals to of ax plus bu, as it is a homogeneous equation, the value of u would be fed as 0, and again I need to discuss about the steady state value of x. In previous problem I was discussing about the worth of the state variable which depends on the time, but here I need to calculate the steady state worth of these state variables. How many number of state variables are getting involved? The 2 number of state variables are getting involved. Agreed? Once this problem is getting over, I would move into the next question. And it is one of the simplified most problem, but still the question repeatedly comes from this zone for maybe 1 mark or at worst 2 marks. Here the matrix A has been given to you, and with the help of matrix A, definitely you can get the characteristic equation, and once the characteristic equation is in your hand, definitely you can get the locations of the closed loop poles. And here it has been asked to get the exact locations of the closed loop pole. Once the 7th question is getting over, straight away we'll jump into the 8th question. In past 2 videos, I did not discuss about the controllability and the observability of the given system. But still, with the help of this question, we are going to unfold the concept of controllability and observability. If you guys have not seen any concept regarding the controllability and observability, but still with the help of these questions, I would be able to communicate all of the important points within the controllability and observability. So we are going to learn about the controllability and observability with the help of this problem. Agreed? This would be the 8th question of the day. Then I would move into the 9th question. More or less here also we are going to discuss about the controllability and the stability of the system. So the 2 problems together, the question number 8th as well as question number 9th, would enlighten the basic concept of the controllability and observability. And after dealing with the question 8th as well as 9th, probably you would be able to smash any problem based on the concept of controllability and observability. Yes. And then we'll move into the 10th question. It is a basic RLC circuit, and here in problem it has been asked how many maximum number of state variable is required to smash this problem or to convert this problem into the form of state space model. That we have already seen, and with the help of that concept we will smash this problem. The two number of state variables are required to convert this electrical circuit into its equivalent SSM. Once this problem is getting over, we are going to take two light numericals. Again, matrix A is known, B is known, C is known. You had to get its damping ratio as well as natural frequency of oscillation. Easily I would be able to get the damping ratio and the natural frequency of oscillation once the characteristic equation is in my hand. Obviously it can be easily retrieved from matrix A. Yes, once this part is getting over, straight away I would be taking the last question of the day, that would be the 12th question, and here again I need to calculate the state transmission matrix, where the matrix A is known to me. And anyways, once the matrix A is known, easily you would be able to get the value of state transmission matrix. So this 12 question I have planned for today's class. This 12 questions I have planned for today's class, and once this 12 questions are getting over, straight away I am going to take probably 3 or 4 number of difficult most problem which have appeared into the GATE examination. So lump sum, my complete concept of the control system or the crash course or the control system will get over in today's class. Agreed? So let me focus over the first question itself. Let me focus over the first question itself. So here comes my first question. Here comes my first question. Yes. You can see it was a linked answer type of question. That means the same statement is true for upcoming 2 questions, for this as well as the questions which would come after this. Yes. Let me read the problem. The problem states, the state diagram of system is shown below. A system is described by the state variable equation. X dot is equals to of Ax plus of Bu, Y is equals to of Cx plus Du. Anyways, we have seen this equation earlier. It's called state equation, and it's called output equation. Now you can see very well, SFG, signal flow graph for a certain system, is clearly visible in this problem. And once you'll go into the 4 different options within the MCQ, your basic intention is to get the value of matrix A, matrix B, matrix C as well as matrix D. Yes. So the agenda behind this problem is very precise and clear. The SFG is given for the given system, and you had to convert the given system into its equivalent SSM. And once you convert any of the system into its equivalent SSM, basically you need to derive the 4 important matrices, and that's nothing but the A, B, C and D. May I know what was the matrix A? The matrix A was system matrix. It was system matrix. May I know what was the matrix B? The matrix B was input matrix. And similarly, what was the matrix C? The matrix C was the output matrix. And may I know what was the matrix D? The matrix D was a feed forward matrix. And I can say it is one of the very, very important problem within the state space analysis. Probably 6 to 7 times the same category of the problem have come, where the SFG of the system was clearly visible over the problem, and with the help of SFG, you need to calculate the matrix A, B, C and D. Agreed? May I know what would be your approach? See, whenever you go ahead with all of the options, at least one matrix would be common in all of 4. Common in all of 4. You can see very well, the matrix B had been the common in all of the 4 options. May I know why they give this sort of information? My dear friends, one thing is quite sure. If two integrating term is being involved in this SFG, definitely it would be an order of 2 system. Why? Because the factor of S square would come towards the denominator system. By default, it becomes an order of 2 system. And if it is an order of 2 system, by default, the 2 number of state variables are required to resolve this problem into the form of SSM. Agreed what I am saying? So few of the important point we should write. First of all, the two integrators are being involved. That means in future, whatever the transfer function would come out from this SFG is gonna be order of 2 transfer function. If order is 2 for the given transfer function, by default, once we will convert the given transfer function into the form of state space model, the 2 number of state variables are required. 2 number of state variables are required. Till this point, nobody should have any doubt. How many number of state variables? 2 number of state variables are required. So may I know which are the point you would be fitting the state variables? See, the first doubt comes into the mind. Mostly the student have got a tendency to feed x1 dot or x2 dot over this node. But this won't be true, or this won't be correct, at least for this problem. See why? So far in a standard problem, I used to take this path as an integrator 1 upon s. So what happens? The integration of x1 dot takes place in time domain and hence it becomes x1. But here, the integrator path had the different or just opposite direction. That means if here the worth is x1 dot, then the integration would be taken place in time domain, and here the input which had been fed to this node would be x1. So nobody should try to think that I should be taking x1 dot or x2 dot over here, and the same process goes with this. Yes, I should not be feeding x1 or x2 dot over here or here. I should feed x1 or x2 dot over here or here. And now what will happen? Now there would be an integration in time domain because of factor of 1 upon s, and similarly there would be an integration in time domain because of the factor 1 upon s. Agreed? Till this point, nobody should have any doubt as such. Now the next important thing comes in a mind. Now the next important thing comes in our mind. Should I take this one as a x1 dot or should I take this as a x1 dot? If I have taken this as a x1 dot, by default it would become x2 dot, and if I take this node as x2 dot, by default it would become a x1 dot. That is what I am saying. It is a type of challenging problem. If you guys have not seen this sort of problem earlier, and if you have not made any practice over this sort of problem, definitely you are going to be stuck in your gate examination. One thing is quite sure, the derivative term of the variables would be kept over here, maybe x1 dot, so it would become x2 dot. If it is x2 dot, by default it would become x1 dot. So may I know, the first node, should it be taken as x1 dot or the second node, should it be taken as x1 dot? Tell me. That is what I am saying. It's a big point or the big ambiguity, which one should be taken as x1 dot and which one is taken to be x2 dot. That is why I used to say, out of A, B, C, D, 4 number of matrix, deliberately they keep one matrix common in all of the 4 options, such that you'll have a fair idea, at least, should I take this as x1 dot or this as x1 dot. You can see very well. -1 and 1, -1 and 1, -1 and 1, -1 and 1. May I know what it indicates? It indicates x dot would be a column matrix, x1 dot, x2 dot. Now you can see very well the x1 dot is getting connected with u with a multiplier factor of -1. And similarly, x2 dot is connected with u with a multiplier factor of 1. So may I know which one would be the x1 dot and which one would be the x2 dot? You can see very well. If you take this as x1 dot, you can see you will reach till x1 dot, taking the multiplier factor of 1 into -1, and the impact of u would be minus of u. So obviously this must be the place of x1 dot, because x1 dot would be decided by u with the multiplier factor of -1, which is common in all of the 4 options. And even you can check for the impact of u over the x2 dot, and that is nothing but the plus. And you can see very well, if you take this node as x2 dot, the impact of u, 1 into -1, that's a -1, -1 into 1, that's a -1, -1 into -1, that's a +1. So the data must be clear to all of us. The variable value at this node is going to be x1 dot, and similarly variable worth at this node is going to be x2 dot. Yes. Now tell me, what would be the value of x1 dot itself? Keep in mind, I have seen while I was discussing the concept of signal flow graph, What it was? Incomer to the any node is going to decide the worth of the variable at that node. So may I know how many number of incomers are coming on this node? Only one incomer is coming, and that incomer is coming from this node. Yes. May I know what would be the worth of this node? You can write it over here. See, the two incomers are coming at this node. The first incomer is coming from u, taking the gain of 1. So obviously it's going to be simply u. And the second incomer is coming from x1 dot, taking the integration in time domain, which is simply x1. Agreed? Till this point, nobody should have any doubt as such. What I am saying? See, the variable worth at this node would be decided by its incomer. How many number of incomer it has? The first incomer is coming from u, taking the gain of 1. So obviously it's going to be u into 1, that's the u. The second incomer is coming from the x1 dot, and now here it is integration in the time domain. So x1 dot becomes x1 itself. Now you can see the worth of this variable is very well known to you, and that's nothing but the u plus of x1. So easily you can write x1 dot. May I know what would be the x1 dot? The x1 dot would be decided by its incomer. Only one incomer is coming, and that incomer is coming through this branch with the gain of -1. That means u plus of x1 would get multiplied with a -1. So here it goes minus of x1 plus of 0 times of x2 and minus of u. Just a minute. Minus of u. Agreed? Till this point, nobody should have any doubt as such. Now, the second node at which the analysis has to be made is nothing but this node. Why? Because it is x2 dot, and definitely x2 dot has to be connected with its state variable as well as the inputs. Now, the worth of variable at this node would be decided by its incomer. How many number of incomers it has? The two incomers it has. The first incomer is coming from x1 dot. What is the x1 dot? The x1 dot is nothing but minus of x1 plus 0 times of x2 minus of u. Till this point, nobody should have any doubt. And now the second incomer is coming from the x2 dot, and within the branch we are getting the gain of 1 upon s. That's the integration in time domain, which simply becomes x2. Agreed? So may I know what would be the x2 dot? The x2 dot, or the variable across this node, would be decided by its incomer. Only one incomer we have, and that incomer is coming through this branch, the gain of -1, and worth of variable at this node. May I know what it is? It's nothing but minus of x1 plus of x2 minus of u. Yes, here goes plus of x1 minus of x2 plus of u. Agreed? Till this point, nobody should have any doubt as such. Yes. So let me focus over these two equations. The first is x1 dot is equals to minus of x1 plus 0 times of x2 minus of u, and the second equation, which is nothing but x2 dot is equals to of x1 minus of x2, and here goes plus of u. So easily I would be able to extract the matrix A. From here you would be able to extract the matrix A. The matrix A is gonna be -1, then it's gonna be 0, then it's gonna be 1, and then it's gonna be -1. The matrix B is common in all of the options, but anyways we can extract that also, and that is nothing but -1 and 1. So may I know which are the options can be ruled out? Obviously B can be ruled out. If we'll talk about the C, even the C can be ruled out. If we'll talk about the D, even the D can be ruled out. And for the better understanding, even you can calculate C also. What does that mean by the C? The C is the matrix which indicates how the state variable is going to affect your output. That you can easily see. See, the x2 dot is straight away coming as the input to the y. So y is simply equals to of x2 dot. May I know what's the worth of x2 dot? The x2 dot is nothing but x1 minus of x2 plus of u. So easily you would be able to get the value of even C also. So the C is gonna be 1 minus 1 plus of u. You can see very well the A is gonna be the best most answer. Yes, one of the most well planned problem I have seen based on the concept of the SFG, and I had to convert this problem into the form of SSM. If it is clear, just write clear. So at least I'll get to know each and everything is clear to all of us. Yes. So the A is gonna be the best most answer. Could you understand what I am saying? Could you understand What are the different points where you guys can make mistake? The first point, most of us have the idea or have just mugged up that here we used to take x1 dot or x2 dot. No, at least in this problem, this fundamental would not be true, because the integration in time domain is not taken in the forward path. It has been taken place into the feedback path. That's the first thing. Secondly, many of us used to have one doubt: should I take this as x1 dot or should I take this as x2 dot? Whenever you come across this sort of problem, always keenly observe the matrix A, B, C and D in all of the 4 options. At least one matrix would be common, which would give a brief idea which should be taken as x1 dot and which should be taken as x2 dot. Secondly, even many of us do not have one idea how many number of variables has to be chosen to smash this SFG into the form of SSM. You need not worry about it. You can see option A, B, C and D. The order of the matrix is 2 cross 2. May I know what used to be the order of the matrix? The order of the matrix used to be number of state variable cross of number of state variable. That means the 2 number of state variable has to be chosen. And I have used all of the process of signal flow graph which we have used earlier, and end of the day I got to know the value of A. Yes. Now, as it has been clearly written, it is a linked answer type of problem. That means the data which we have concluded over here, either matrix A, B, C and D, that would be useful for the further calculation or the calculation for the second question. Anyways, keep in your mind the matrix A is this, matrix B is this, matrix C is this and matrix D will be this. So let me go into the next question. Yes. I need to calculate the state transmission matrix or state transition matrix. Keep in mind, whenever you need to calculate the state transition matrix, only one simple formula has to be used. Although in last class I could not derive it, but you can just by heart how to calculate the state transition matrix when the matrix A is known. One of the very important fact, for the calculation of the state transition matrix, the matrix A is more than sufficient, which was calculated earlier. May I know what was the matrix A? The correct answer was option A. That means the correct answer was minus 1, 0, 1, minus 1. Minus 1, 0, 1, minus 1. Minus 1, 0, minus 1, 0, 1, minus 1. This was your system matrix. Yes. And you want to calculate its state transition matrix, which we call it phi of t. Keep in mind the phi of t is also written as e to the power of at, and it is being written as Laplace inverse of si minus of a, which would be a matrix inverse of it. Yes. Did you understand what I am saying? That means first you have to find the matrix A, which is nothing but the system matrix. Then you have to find another matrix Si minus A, and you have to take the inverse of it. So obviously you have got another square matrix with the order of. May I know what would be the order of this matrix? The order of the matrix is going to be n cross n. May I know what is the n over here? The number of state variable. What is the n over here? Is number of state variable. So put together, whenever we deal with the state transition matrix or e to the power of at matrix, the order of e to the power of at matrix is always going to be a square matrix, and the order is precisely going to be number of state variable cross of number of state variable. Yes. So let me focus over the first matrix, and that is nothing but the Si minus of A. So definitely I would frame Si minus of A matrix first. May I know what it would be? It would be S plus of 1, here it would be 0, here it would be minus 1, and here it would become S plus of 1. I need to take the inverse of it. How the inverse of a square matrix is being taken? First I take the adjoint at numerator, and at denominator I used to take its determinant. If you are dealing with the 2 cross 2 matrix, the calculation of its adjoint is very easy. May I know how we will do that? There would be exchange of their principal diagonal elements. That means this S plus 1 would get to this point, and similarly this S plus 1 would get to this point. Although here both of the terms are same, that is why it may not be looking different, but yes, whenever you deal with the any 2 cross 2 square matrix, and if you have come across a situation where the adjoint has to be taken, so definitely their swapping has to be done. If the swapping has been done, still it is s plus 1, still it is s plus 1, and there would be the multiplication over the off diagonal matrix, and that is nothing but 1, and here becomes 0. Here becomes 0. At denominator, the determinant of the matrix Si minus of A would come into the picture, and that is nothing but the Si minus A inverse, s plus 1 to the power of 2. Yes, and you guys are well aware, if the multiplication or division in any certain matrices takes place, keep in mind that factor would get multiplied or divided in each and individual factors. So here goes Si minus of A, which is equals to of 1 divided by of s plus 1 to the power of 2. Now the s plus 1 divided by of s plus 1 to the power of 2 is messes each other. The factor which should be left out is simply 1 divided by of s plus 1. 0 divided by of a non-zero quantity would be 0. Here goes 1 divided by of s plus 1 to the power of 2. 1 to the power of 2, and here goes 1 upon s plus 1. And once I take the Laplace inverse of Si minus of A inverse, by default, I get the state transition matrix. May I know what would be the Laplace inverse of 1 upon s plus 1? That's quite self-explanatory. That's nothing but the e to the power of minus t. Here is 0, here is 0, here is e to the power of minus t. See, when the square of the denominator takes place, that takes place only and only if the differentiation has been made in S domain. You can see very well, e to the power of minus t was leading s plus 1 at denominator. If now you are forcing to have the differentiation in S domain, what would happen? The function of denominator would become a square. So how the differentiation can be forced in the Laplace domain? That can be forced just by multiplying t, So just try to get the Laplace transformation of t into e to the power of minus t. So the Laplace of e to the power of minus t is nothing but 1 upon s plus 1, and because of t there would be a differentiation in Laplace domain one time, and here minus 1 to the power of n. What is the n over here? The n is nothing but the power of t, that's simply 1. So from here we get to know the answer. At denominator the square would take place, and that is nothing but the s plus 1 to the power of 2. Here goes s plus 1 differentiation of numerator, that's simply 0, and here goes minus of 1 differentiation of denominator, that's simply 1, and keep in mind this minus and this minus goes off. So you can see very well the Laplace of t into e to the power of minus t is nothing but 1 divided by of s plus 1 to the power of 2. So here you can write this as t into e to the power of minus t, t into e to the power of minus t. So the best most answer is again gonna be option A. Yes, many of us have started giving answers, so probably both of the two problems. The first problem where I wanted to convert the given signal flow graph into its SSM model could have understood to all of us, and with the help of the first outcome, which was nothing but the matrix A system matrix, I need to get the state transition matrix, that also could calculate it. Yes. Now let me go into the third question. And this question is more or less same as the first question, where the SFG for the given system has been clearly visible within the problem itself, and from that SFG you had to withdraw its matrix A, B, C as well as D. May I know what would be the best most answer for this given problem? Again, before starting this problem, let me write few of the important points. How many integrators are getting involved within this system? The two number of integrators are getting involved within this system. What does that mean of it? That means the order of the system is 2. If the order of the system is 2, definitely the two number of state variables are required to convert this SFG into the equivalent SSM model. And even once you'll see option A, B, C and D, the order of the matrix of A is 2 cross 2. That's self-explanatory that yes, the two number of state variables are required. If you want, I can write somewhere here the important point. The important point I can write, the two number of integrator indicates in future if I would be calculating the transfer function or the net transmittance of the given SFJ, it would be in order of 2. So how many number of state variables are required? State variables are required, which is exactly 2. Even you can cross check from the given options also, and you can see very well the matrix A used to have the order of n cross n, where the n used to be the number of state variable. state variable. Number of state variables. Yes, tell me what would be the best most answer for this. Again, the same problem would come into the picture. First, should I take this one as a x1 dot or should I take this as a x1 dot? If I take this as a x1 dot, alternatively it would become x2 dot, or if I take this as a x1 dot, alternatively it would become x2 dot. And now you can see very well, there is an integration in the forward direction, so obviously I would be taking the derivative of the state variable at this point, so that in future the integration would take place in time domain, and similarly in future the integration would take place in time domain. Again the same problem comes in our mind. Which one must be chosen as x1 dot? Should I choose this as x1 dot or should I choose this as x2 dot? Now I want the reply from each one of you. Should the first node be chosen as x1 dot? Should the second node be chosen as x2 dot? I want the reply over the live chat. Again the same fundamental has to be used. Once you look it into the each and individual options, among matrix A, B and C, one matrix would be uniform in all of the options, just to give an idea which node has to be chosen as x1 dot and which node has to be chosen as x2 dot. You can see very well which data is same. The matrix B is same in all of the four options. So one thing is quite self-explanatory. With the help of matrix B, I would be able to judge which node would be x1 dot and which node would be x2 dot. Yes, try to understand in this way. See, if I take the first node as x1 dot, by default the integration to this point would become x1. Yes, that means the node worth would be decided by its incomer. How many number of incomers we have? The two number of incomers we have. The first incomer is coming from x1 dot, taking the integration, it would become just x1. And if I take this as x2 dot, the integration of x2 dot is simply x2. Here it comes back. So if I take this as x1 dot, may I know what would be the worth across this node? What would be the worth across this node? The worth across this node would be the integration of x1 dot, that simply equals to of x1, that's the first incomer. May I know what about the second incomer? If I have taken this as x2 dot, it has been x2, and now you can see very well with the help of gain of -1, it has been come back. Agreed? Now you can see very well, if x1 minus of x2 has been processed further, you can see very well what would be the impact now. I want the input from each one of you, which must be chosen as x1 dot and which must be chosen as x2 dot. Tell me. Which must be chosen as x2 dot and which must be chosen as x1 dot. So if you'll do a little bit self-analysis, you would get to know the first has to be chosen as x2 dot. Now I would expect most of us would have a clear-cut idea. The first node has to be chosen as x2 dot and the second node has to be chosen as x1 dot. Not this one, x1 dot. Yes, x1 dot. Yes, so may I know how the x2 dot has to be defined? The x2 dot has to be defined by its incomer, and keep in mind the x2 dot can be only defined with the terms of state variables as well as the input. So let me write about the x2 dot. So x2 dot have got the two incomers from the input itself. So here goes x2 dot has the first incomer from the input itself, and that is nothing but the 2 times of US. And you can see very well, the x2 dot has to be decided by the incomer. Yes, it has to be decided by the incomer, and the gain has to be 2. If you take this as x1 dot, by default x1 dot would be decided by the input with the gain of 2. But once you'll see the matrix B, this thing is quite self-explanatory. The x2 dot has to be decided by u with the gain of 2. Agreed? That is why I have chosen this as the x2 dot and this as the x1 dot. Yes, agreed? No? Could you understand what I am saying? See, deliberately I have taken this problem because this is the problem where most of us used to have doubt which has to be chosen as x1 dot and which has to be chosen as x2 dot. What I wanted to communicate, out of the 4 different options, one matrix would be common, like matrix B is the common matrix, and once you will try to extract the information from the matrix B, you will get to know here the x2 dot is getting decided by u with the gain of 2 everywhere. So definitely it has to be x2 dot, then only it would have an incomer from you with the gain of 2. And if it is x1 dot, the x1 dot is not at all directly connected with the input, and that is why this factor is absent. This factor is absent. Agreed? Till this point nobody should have any doubt as such. So tell me what's going to be the x2 dot? The x2 dot have got the 2 incomers from where? This is x1 dot. So definitely there would be the integration in time domain once I'll go forward. So simply it would be x1 because it has got only one incomer and that is coming through this branch. Yes. So tell me what's going to be the x2 dot. The x2 dot is going to be minus times of x1. Yes. Minus times of x1 plus of 0 times of x2 plus of 2 times of us. 2 times of us. In Laplace domain, usually I used to write in time domain because the differentiation has been written in time domain. Agreed? Till this point nobody should have any doubt as such. Now goes the second one. That is nothing but x1 dot over here. x1 dot over here. Now you can see very well this node have got the 2 incomer. The first incomer is coming from x2 dot taking the gain of 1 upon s. That means integration in time domain. The x2 dot would simply become x2. Okay sir, no issue as such. It would simply become x2. Yes, this path is processed and now the next incomer is coming from the x1 having the gain of minus 1. So here goes minus of x1, here comes 0 of u, 0 of u. Agreed? If we'll talk about its matrix, may I know what would be the matrix over here? The matrix is gonna be minus 1, 0 and plus 1. That would be your matrix A. That would be your matrix A. And if we'll talk about the matrix B, may I know exactly what would be the matrix B? The matrix B is gonna be 2, 0. Anyways, the 2, 0 is, sorry, the mistake has happened. Just a minute. It has to be just reversed. It has to be just reversed. What it is, just a minute. This is nothing but the x1 dot, no? So this factor would come at top side, so it's gonna be minus 1. Here it's gonna be plus 1, here it would be minus 1, here it would be 0, and that would be matrix A. And similarly, if we'll talk about the matrix B, that would be 0, of 2, 0, of 2. Agreed? So here is gonna be minus 1, 1, minus 1, 0. What are the datas can be ruled out? Definitely A can be ruled out. Then C can be ruled out. So only we have been left out with the B and D. Tell me which would be the best most answer. Now we also had to process the matrix C because the matrix C had got the differences in both of the options. Tell me how the matrix C is being defined. The matrix C is the bridge between the state variable and the output. Yes. So we'll try to understand how the output is getting connected with the state variable. You can see very well. So just focus over this node. And now the worth at this node is getting gain of 0.5 before getting processed as output. May I know how many number of incomers it has? Yes, the 2 number of incomers it has. From where? The first is coming from x1. Yes. And the second is coming from this node. What it is? It's nothing but the x1 dot. What is the x1 dot over here? The x1 dot is nothing but minus of x1 plus of x2. That's it. Yes, once you'll add them together, the x1 and x1 goes off. So the worth of that node is simply gonna be x2. The worth of this node is simply gonna be x2. Now before getting processed with the 0.5, now the y of s is simply gonna be 0.5 times of x2. 0.5 times of x2. Agreed what I'm saying? 0.5 times of x2, you will get the exact answer for this. And that is nothing but 0.5 of x. So the B is gonna be the best most answer. Agreed? Option C. Any mistake has happened? Anyways, you can cross check by yourself. Agreed? Till this point, nobody should have any doubt as such. Yes. So the process is more important. Now here comes the next question. Yes, here comes the next question. The zero input response of a system given by the state space equation. Probably one question has been left out, no? Yes, One question was left out. Yes, with the help of the earlier information which we have concluded in the question number 3, I need to get the transfer function. I need to get the transfer function. So the best most answer, what it was, the best most answer was option B. The value of A was -1, 1, -1, 0, 0, 2, as well as the value of C was 0, 0.5. I need to write somewhere, then only I can proceed further. I need to write somewhere, then only I can proceed further. So tell me, with the help of option B, I need to get the transfer function of the system. I need to get the transfer function of the system. You guys would be able to recall what was the transfer function which relates the matrix A, B, C, D with the transfer function of the given system itself. Yes. Tell me how the transfer function was calculated. If you guys would be able to recall the formula which I derived in the last class, the transfer function can be related with the matrix A, B, C, D in the form of C Si minus of A inverse gets multiplied with B plus of D. At least in this problem you can see very well the matrix D is a null matrix. The output was not straight away getting connected to the input. So with the help of matrix C, the inverse of Si minus A as well as B, I need to get the complete transfer function. Tell me what would be the best most answer. First have the value of C, that is nothing but 0, 0.5. Then focus over the Si minus of A inverse. What it would be that? It would be S plus of 1. Here it would be -1. S plus 1, 0. You had to take the inverse of it. Yes. And then it gets multiplied with the matrix B. May I know what it would be? It would be 0 and 2. 0 and 2. Agreed? Till this point, nobody should have any doubt as such. So here comes 0, 0.5. If we had to focus over the inverse of this square matrix, what would be the procedure? If it is a 2 cross 2 in nature, definitely their diagonal element would get swapped. So this 0 would come over here, this S plus 1 would come over here. So here goes 0, here comes S plus 1. No doubt as such. And here goes S plus 1 gets multiplied with a minus sign, and here it would become +1. And now it has to get multiplied with 0 and 2. Agreed? Till this point, nobody should have any doubt as such. And at denominator, I need to take the determinant of this matrix. May I know what it would be? So obviously, this is gonna be S plus 1 is getting multiplied with 0, and here it's gonna be simply S plus 1. Yes. Now tell me what is going to be the transfer function. Before getting the transfer function, you can use a simplified method. See, one mistake you guys are going to do, you are just straight away going to multiply this matrix and thereafter this matrix with this matrix. You can do one thing. You can take 0.5 common out of this row matrix. Obviously, sir, I have taken 0.5 common from this matrix. It would become 1. Yes, and similarly I would take 2 common from this column matrix. Yes sir, that would be also done. And once you multiply them together, it would be simply 1. That means now this row matrix has become 0 and 1. It became a square matrix, and now it is a column matrix with element of 0 and 1. And end of the day, once you multiply them together, you would be getting its denominator as well as numerator. End of the day, you would be getting the answer of it. Anyways, the answer has been precisely calculated. The answer is somewhere C. The best most answer which we are getting is nothing but the option C. Yes. So the starting 4 number of problems which I have taken, no, they were linked based on the problem. That means the same statement was true for the first as well as the second question. The output from the first question would serve as the input to the second question, and that is why they used to call it as a linked based question. But keep in mind, from the CBT onwards, that means from the day the gate has started giving the CBT test, the linked type of questions are not the part of your paper pattern itself. No, so this sort of problem is not going to come, but still the concept can be copied. So within the 4 number of problems, what are the different details we could extract? The first as well as third problem, I could know from the given SFG how to extract the matrix A, B, C and D. Similarly, with the help of second question, when we know the matrix A, at least I have got the idea that how to calculate the state transition matrix e to the power of at or phi of t. And similarly, with the help of fourth question, I could know if you know the matrix A, B, C and D, here the D was 0, how will you get to know about the transfer function of the given system? That is also known to me. That is also known to me. If it is clear, just write clear somewhere. So I'll have a bit idea that each and everything is well clear to all of us. Well clear to all of us. Yes. Here comes the next question. You can see very well the problem have appeared in GATE Electronics year of 2003. The problem was framed by IIT Madras. So let me read the problem word by word carefully and we'll try to decode this problem out. See what the problem states. The zero input response of a system given by the state space equation. Here the datas are being given. Yes. Then the state space equations are to be extracted from the above given equations. Above given equations. May I know what does it mean by the zero input response? Zero input response. If you will refer back the state equation, the derivative of these states were dependent on the state variables itself and the physical input u itself. Physical input u itself. It's a specific condition where I do not have any physical input. That means the state variables are just dependent on the state variables only. This is nothing but null. Null would be the better word. Null would be the better word. That means in case of zero input, state equation can be written as x dot is equals to of ax. X dot is equals to of ax. Yes, till this point nobody should have any doubt as such. And we are focusing over the worth of x. Easily worth of x can be calculated, and once you will visualize the option A, B, C and D, the value of x has been written in terms of time domain. That means I need to get the solution of this differential equation obviously in time domain. So what I would do, I would take Laplace both side. I would take Laplace both side. Both side. If I'll take the Laplace both side, it would become s times of x of s. Yes. So far, while analyzing the system in terms of transfer function, I was dropping the initial condition, but here the initial condition is not 0. And keep in mind, if the initial condition itself would be 0, the value of x would be 0, because there is no physical input and there is no initial condition. What does that mean of it? That means the system was kept at a complete rest. At a complete rest. Agreed? So what I would do is going to be s times of x of s minus of x of 0 is equals to of a times of x of s. What I would do, I would shift a times of x of s towards left hand side, and whatever the operation has to be carried out now, they had to be in align with linear algebra because they are in a form of matrix. So here goes s of I minus of a x of s is equals to of x of 0, x of 0. Agreed? So here comes x of s is equals to of what I would do, I would multiply s I minus of a inverse both side. So it would become identity matrix, and towards right hand side it would become s I minus of a to the power of minus 1 getting multiplied with the x of 0. Anyways, the calculation has to be made over the time domain. I would take Laplace inverse both of the side. So here it would become the matrix of the state variable is equals to, I would take a Laplace inverse of si minus of a to the power of minus 1, that is nothing but phi of t e of at, and that is nothing but the state transition matrix. That is why the state transition matrix is so important matrix, because straight away it connects the initial condition with the state variables, or the initial conditions of the state variables with the time domain state variable. Time domain state variable. Yes, here goes x of 0. Yes, so again you had to follow the same process, and end of the day you had to get the answer. So may I know how the phi of t has to be calculated? we had to take the inverse of Si minus of A. So here becomes S of minus 1, here it's 0, here it's a minus 1, here it's a S minus 1. You had to take inverse of this matrix, and end of the day you had to take its Laplace inverse. May I know what would be the inverse of this matrix? There would be the swapping between the diagonal elements. If the diagonal elements get swapped, the S minus 1 would remain at its place. Similarly, this 0 would remain 0 and this minus 1 would become plus 1. Agreed? That is nothing but the adjoint of the given matrix. And at denominator, we had to get the determinant of this matrix. May I know what would be the determinant? It's simply going to be S minus 1 to the power of 2. S minus 1 to the power of 2. Agreed? And end of the day, I need to take the Laplace inverse of it. Laplace inverse of it. So obviously, S minus 1 to the power of 2 would get divided with the S minus 1 as well as S minus 1 as well as 1. So what would be that? So simply it's going to be Laplace inverse of 1 divided by of S minus 1. Here it becomes 0. Here it is 1 divided by of S minus 1 to the power of 2. And here going to be 1 divided by of S minus 1. Yes, till this point nobody should have any doubt as such. And end of the day, if I take the Laplace inverse of each of the individual component, 1 upon S minus 1 would lead the Laplace inverse as e to the power of t. Here it's going to be 0, here it's going to be t into e to the power of plus t, and here goes e to the power of t itself. So you know the factor of phi of t, and that is nothing but the e to the power of t, 0, t into e to the power of t, and here it's a e to the power of t, and that's going to be multiplied with the worth of the state variable at t is equals to 0. May I know what it is? It's nothing but the 1 and 0. 1 and 0. The order of this matrix is 2 cross 2 and the order of this matrix is 2 cross 1. So obviously the resultant is going to be 2 cross 1. Let's multiply them. So here it's going to be e to the power of t would get multiplied with 1. That would be e to the power of t itself. Now the 0 gets multiplied with the 0, the addition with the e to the power of t would remain 0. Now t into e to the power of t would get multiplied with 1, e to the power of t would get multiplied with 0, so their addition is simply going to be. Yes, till this point nobody should have any doubt as such. So the best most answer is going to be C. Keep in mind, A cannot be the answer at all. Why? The worth of state variable at t is equals to 0 is precisely given, which is nothing but 1 and 0. Here, if you'll feed t is equals to of 0 over this state equation, you'll get to know once you'll be feeding t is equals to 0, the first component becomes 0 and the second component is also 0, which is not true from the given information. Similarly, if you'll come to the option number B, in option number B, if you'll feed t is equals to 0, it becomes 1 and it becomes 0. So obviously, it is trying to satisfy the requirement. If you'll go in option C, it becomes 1 and as well as 0, and if you'll go into the option D, it becomes 0 and 1. So obviously, B, which are the options could not be the answer at all. So obviously, the A and D is not the possible answer at all. So the person who tries to give the answer in terms of A and D, he would be the last person of the year. Anyways, the best most answer, which one is going to be the best most answer? C is going to be the best most answer. No, my dear friends, try to understand in this way. The xt is not response, they are state variables. But the output has to be decided by these state variables as well as inputs, no? So in future, even the state variables can also be said to be the response of the individual nodes. Try to understand in this way. As far as a certain node is concerned, the worth of the node is being defined by their state variables. So you can say the response of that node is nothing but the state variable. Did not to have any confusion as such. Agreed? Till this point, each and everything must be clear to all of us. Here comes the sixth question. For the homogeneous state equation, what does that mean by the homogeneous state equation? If you would be able to recall what we have studied in form of linear differential equation, I have taken the two different form of the linear differential equation, in homogeneous form and homogeneous form. In case of homogeneous linear differential equation, the input has been forced to 0. So whenever you have this terminology, the homogeneous system, that means it is a type of 0 input system. Yes, this part must be clear to all of us. There should not be any doubt as such. Agreed? Now, if we'll talk about the x of s, just in the last calculation, I calculated the value of x of s, or the Laplace of the state variables. How many number of state variables are getting involved with this problem? The 2 number of state variables are getting involved in this problem. So it would be x1s and it would be x2x. And here goes si minus of a inverse, which is getting multiplied to the worth of the state variable at t is equals to 0, or the initial conditions of these state variables. Agreed? So far in the last problem, we were interested finding the value of x1 and x2, how it is changing with respect to the time. But here my intention is a bit different. I am just focusing over the steady state values of the individual state variables. What does it mean of it? Either you can solve this problem in the 2 different methods. First, you can get x of t. How the x of t can be calculated? I can take the Laplace inverse both of the side. So it would become x of t, it would become phi of t e to the power of at state transition matrix, which we can calculate because I have done it 2 times, probably in second questions and just last question, and then straight away I would be multiplying with the x of 0, and end of the day I would be feeding t tends to infinity. So I'll get to know what is the steady state value of x1 as well as x2 when the t tends to infinity. Or the second methodology could be, you can just multiply, the conclusion or the outcome would be in Laplace domain, and after that you can apply the final value theorem. Which one would be the better method? Obviously the final value theorem would be the better method, because you need not to convert the given function into the time domain, and straight away within the Laplace domain you would be able to get the final worth of the individual state values x1 as well as x2. Agreed? So I would be using the final value theorem. This was the point where I have seen many of the students would go into the longer process. First they would get the value of x of t, then they will be feeding t tends to infinity in x1t as well as x2t, and unnecessarily they are wasting their time. So let me focus over this. I would be taking the inverse of it. May I know what would be the inverse? The inverse is going to be si minus of a. This is nothing but a matrix A where the x dot connects with x. Yes, it's a matrix A. So here becomes s plus of 3. Here becomes minus 1, here becomes 0, and here becomes s plus of 2. I need to take the inverse of it. Yes, I need to take the inverse of it, and thereafter it has to get multiplied with the x of 0. The x of 0 is clearly given to me, and that's nothing but the 2 minus 1. 2 minus 1. And that is going to be decided your x of s. Although x of s is also being decided by the input itself, but this was a specialized case of the system where the physical input was 0. Agreed? May I know what would be the best most answer? Just take the inverse of it. If you take the inverse, there would be a swapping, s plus 2, s plus 3, minus would become plus, 0 would get multiplied with the, and would remain 0. Yes. And at denominator, what's happening over here? Obviously the determinant has to be taken, and that's nothing but the s plus 2 into s plus 3. S plus 3. Here goes 2 and minus 1. Here goes 2 and minus 1. Yes. You can do one thing. You can keep s plus 2 into s plus 3 separately. Just multiply this square matrix with the 2 minus 1. The order of this matrix is 2 cross 1. Order of this matrix is 2 cross 1. Their multiplication would be in order of 2 cross 1. So do one thing. Keep s plus 2, s plus 3 out. And just have the multiplication between them. Yes. So the s plus 2 would get multiplied with 2, that would become 2s plus of 4. 2s plus of 4. 1 would get multiplied with the minus 1, would become minus of 1. So the 2s plus of 4 minus of 1, that would become 2s plus of 3. Agreed? The same process goes with the second. The 0 gets multiplied with the 2, that would become 0. And now the s plus 3 has to get multiplied with the minus 1, and that's nothing but the minus times of s plus 3. Agreed? And once I would multiply inside, so the factor which would be left out is simply going to be, you can see very well, here it is 2s plus of 3 divided by of s plus 2 into s plus 3. Similarly, if we'll talk about the second one, it's simply going to be minus of s plus 3, which is getting divided by s plus 2 into s plus 3, and here the s plus 3 and s plus 3 is getting cancels out. So the factor which would be left out is simply going to be 1 divided by of s plus 2. And now you can see very well, they are the functions in Laplace domain and you wanted to convert them into the time domain and you need to feed t tends to infinity, why don't we use the final value theorem itself? So you would be using the final value theorem in the each and individual functions of S. So may I know how we'll be applying the final value theorem? So the final value theorem would be limit S tends to 0, S times of the function of S itself, which is nothing but 2S plus of 3 divided by of S plus 2 into S plus 3. You can see very well there is no component of S towards the denominator side, that means there would not be any cancellation of S towards the numerator as well as denominator. This factor would become 0. So the steady state value, that means the value of x1t when the t is tending towards infinity is 0. Similarly, the same process has to be taken for the last. There also you would be getting the value of limit t tends to infinity of x to t s0. So the best most answer is gonna be A. So you could have seen the two problems were based on the concept of zero input response or homogeneous state response, and the problem do come repeatedly from this domain. That is why I have taken one problem out of this. So let me take the next question. The seventh question is type of straight problem and the derivation is already been made probably in last class. Anyways, let me focus over the problem. What the problem says precisely. The state variable description of a linear autonomous system is x dot is equals to of ax. Again you can see, although matrix B for this system would not be 0, but the BU factor has been neglected. What does it mean of it? Again, it's the case of zero input response or the case of homogeneous state. Yes, where x is the two-dimensional state vector and A is given by. So obviously matrix A, which is nothing but the system matrix, has been clearly given to you guys. Yes, and may I know what we wanted? We wanted to know the exact locations of the system whose system is being represented by the system matrix A. Yes. Anyways, if you would be able to recall what we have studied in the last class, if you know the system's transfer function, the denominator has to get compared with 0. Whatever the root comes out, they are nothing but the poles of the given system. That's the first approach. Even with the help of matrix A, we can get the exact locations of pole. For that, first we need to get the characteristic equation. How the characteristic equation is being defined? It's been defined as a mod of Si minus of A gates compared with 0. If you do not have an idea from where this formula has been derived, you can go through my last video. So here goes S gates subtracted with 0, that's simply S. Here comes plus of 2, here comes plus of 2, and here goes S itself. I had to take the mod of this matrix and thereafter has to get compared with 0. So here the S and S gets multiplied, here it's going to be S square, and here it becomes minus of 4 would be compared with 0, Yes. So obviously it can be written as S square minus of 2 to the power of minus 2 is equals to 0. So in the terms of factor, it can be written as S minus 2, S plus 2 is equals to 0. Once I will compare the first factor with the 0, I would be getting the root S plus 2. And if I will compare the second factor with 0, I would be getting the root S minus 2. So the best most answer is going to be option A. In the same sequence, let me take the next question. Yes. See, again the system was represented by its system transfer function or system equation, which we call it state equation. I would repeat what has been clearly given on this problem. The system x dot is equals to of ax plus bu with a is equals to this, b is equals to this. Then find the system is a stable system, controllable system, non-stable system, non-controllable system. So put together, you had to focus over the two important control system parameters, and that is nothing but the controllability, and the second is stability. Agreed? So far we have not seen about the controllability. But yes, we have seen about the stability. How a system would be said to be a stable system? Definitely based on their closed loop poles. How the closed loop poles would be calculated? From the characteristic equation. How the characteristic equation would be calculated? From the system matrix. And you know very well, the stability can be judged from the roots of the characteristic equation, and the characteristic equation is nothing but the mod of Si minus of A is equals to of 0. The same problem I have just taken earlier. So here goes S plus 1, it's a matrix A, it's a minus 2, it's a 0, it's a minus 2. Yes, I had to take the mod of it, compare with 0. So what happens? Once I will be multiplying them together, it's going to be minus 2s minus of 2 is equals to 0, okay? So this minus sign and minus sign goes out, so the s is going to be minus 1 divided by of 2. Any mistake has been taken place? Let me check it out. It's going to be s plus 1, it's going to be minus 2, sorry, here it's going to be s minus 2. Yes, mistake was there. Here it's going to be s minus 2, agreed? So once we'll multiply or we'll take its determinant, so the factor which would come out is simply going to be s plus 1 would get multiplied with the s minus 2, minus 2 would get multiplied with 0 would become 0 simply, and now the s plus 1 and s minus 2 has to get compared with 0. So now you can see very well the order of the system is 2, that is why the degree of the characteristic equation is 2, and once we'll compare s plus 1 with the 0 and s minus 2 with the 0, you will get to know the one pole is placed towards the left hand side of the j omega axis on S plane, whereas the another pole is kept towards the right hand side, and hence the system would be an unstable system. Yes. Now for the controllability, we had to perform Kalman test. How is being referred? We need to take a matrix. The matrix is going to be B, AB, A square B till A to the power of n minus 1 into B. May I know what does it mean by the n? The n is nothing but the number of state variables, or nothing but n is nothing but the order of your matrix A, n cross n. Yes, n is nothing but number of state variables. Yes, now you can get the rank of this matrix, but that process unnecessarily bring so much complexity. So I will do one thing, just focus over its determinant. If the determinant is 0, keep in mind, if determinant is 0, the system is not fully controllable. Anyways, the partial controllability, I am not going into that detail, but yes, it would not be fully controllable. Controllability test is fail, it's going to be an uncontrollable system. And if its determinant is not equals to 0, the system is called to be a controllable system. So again, we had to focus over this matrix. First we had to get this matrix. May I know what is that? The first matrix is a column matrix, which is nothing but B, 0 and 1. The second is going to be AB. That means this matrix and this matrix has to get multiplied. May I know what would be their multiplication? It is in order of 2 cross 2. It would be in the order of 2 cross 1. Their multiplication would be in order of 2 cross 1. So let's start doing multiplication. See, minus 1 would get multiplied with 0. That's simply 0. 2 would get multiplied with 1. That's simply 2. So the 0 plus 2, that's simply 2. Yes. Now similarly, the 0, 2 gets multiplied with 0, 1, 0 gets multiplied with 0, that's 0, 2 gets multiplied with 1, that's 2, agreed? And here comes 2 and 2, I would get its determinant. May I know what's going to be its determinant? 0 gets multiplied with 2, that would become 0, put together it's simply equals to minus 2, which is not equals to 0, it is a type of controllable system. So what's going to be the best most answer? Stability, no sir, it was not stable. So A and B has been ruled out. So you have been left with the C and D. If we'll talk about its controllability, whether it was a controllable system, obviously sir, it was a controllable system. So the best most answer is going to be option C. Yes, nobody should have any doubt as such, at least till this problem. Now this is the next level problem, because in the previous problem I was just focusing over the controllability, but in this problem we are going to focus over the controllability as well as observability. Anyways, I am not going into the core detail of the observability and what controllability, what does it practical mean of it, but still you must have a clear-cut idea how to approach problem related to the controllability and observability. I have taken one problem based on the controllability. Now the second problem talks about the controllability as well as observability. Anyways, let me focus over the problem. The problem have come in GATE Electronics year of 1992. The problem was framed by IIT Delhi. Let's see what the problem states. A linear time invariant system described by the state variable models. Obviously, you can see very well the first information which was given is nothing but state equation, which used to be x dot is equals to of ax plus of bu. So you can see very well it is my matrix A, it is my matrix B, it is my matrix C, and probably the matrix D is a null matrix. Yes, null matrix. Anyways, once we focus over the controllability and observability, in case of controllability test, you need to have the two inputs, matrix A, which is nothing but the system matrix, and matrix B, which is nothing but the input matrix. Similarly, once we discuss about the observability test, we need to have the two matrix as the input. First is going to be system matrix and the second is going to be output matrix. Again, we'll recall what formula I have used for analyzing the controllability. What it was? It was I need to take the mod of the matrix BAB. If it is 0, all of these state variables are not controllable, but you need not to bring so many complexity over here. If the result is 0, the controllability test is failed. Keep in mind it's a non-controllable system. And similarly, if the determinant is non-zero, by default it becomes a controllable system. So focus must be over the BAB. The B used to be a column matrix, which we have seen. So the B is going to be 0 and 1. What's going to be AB? Their multiplication. So the multiplication is going to be -1 would get multiplied with 0, that would become 0. 0 would get multiplied with 1, that would become 0. And now you can see very well, you need not to even calculate the next component. If any of the complete row or column vanishes in a square matrix, its determinant becomes 0. I do not even care whatever the data is coming over here. The result is going to be 0. What does it mean of it? No. The given system is not fully controllable. Anyways, fully and partially is not there in the syllabus. Just they would ask whether it's controllable or not. Definitely it's not controllable. Yes. Now if we'll talk about the observability. How the observability was checked. For that, again we used to take another observability matrix, which we call it MO. Observability matrix. What used to be the structure of the observability matrix? Instead the B, we start with C. Yes. And there used to be AB, A square B. Here it used to be CA square, and again it would go till CA to the power of n minus 1. And you can see very well the C used to be a row matrix. What would be the structure of this matrix? Obviously it has to be a square matrix. With the order of n cross n. See, I have seen many of the times the student used to have confusion. Sir, the square would take place for the C or the square would take place for the B. See, my dear friends, the square is possible only and only for the square matrix. Yes. You cannot do the squaring of any column or row matrix which does not be in an order of column matrix. Yes, the square is possible only and only for the square matrix. That means in future, even for the column matrix or in future for the controllability test, where I use the formula A square B, square is already been applied over the A only, and similarly the same process is being followed over here also. Agreed. Till this point nobody should have any doubt as such. Agreed. So I would be using the structure. May I know what would be the structure? The number of state variables are 2, so obviously it would be in order of 2 cross 2. And the same process goes on. You had to take the determinant of the given observability matrix. If the determinant is 0, the observability test is failed. That means it is not fully observable, and if the result is non-zero, keep in mind it becomes fully observable system. Fully observable system. Agreed? Till this point, nobody should have any doubt as such. So tell me what's gonna be C over here? C is gonna be 1 and 2. What's gonna be CA? 1, 2 has to get multiplied with, just a minute. 1, 2 has to get multiplied with minus 1, 0, 0, minus 2. Their multiplication would be in order of 1 row, 2 column. It would be in order of 1 number of row, 2 number of column. So 1 gets multiplied with a minus 1, it would become minus 1. 2 would get multiplied with 0, that would remain 0. It's going to be minus 1. Similarly, 1 gets multiplied with 0, that would remain 0. 2 gets multiplied with minus 2, that would become minus 4. So here goes minus 1, minus 4. Yes. So let me focus over the determinant. Let me focus over the determinant. So here goes its determinant. Here goes its determinant. So the determinant is going to be minus 4 would get multiplied with 1. That's simply minus 4. And similarly, minus times of minus 2. And you can see very well which stands for minus 2, which is not equals to 0. Which is not equals to 0. So you can say, yes, the given system, whether it's a controllable, no, it is not fully controllable. If it is observable, yes, it is fully observable. It is fully observable. Anyways, what would be the best most answer? B. It is not fully controllable. It is not fully controllable. Yes. Till this point, nobody should have any doubt as it. The next question is the simplest question of the day. The problem have appeared in GATE instrumentation year of 1994. The problem was framed by IIT KGP. Anyways, let me read the problem carefully, and you guys had to give the proper answer for this given problem. The minimum number of state required to describe the network shown in figure. When the state variables are required, obviously when the electrical circuit gets converted in the form of SSM, state space model. How many number of state variables are required to resolve this electrical network into the form of SSM? That solely depends on the effective number of energy storing element. Second, the order of the system. Once you will calculate the order of the system or effective impedance of the system, you will get to know because of L, you would have Ls, because of C, you would have 1 upon Cs, and the effective order of the system is simply going to be 2. Or in the different way, you can see the first state variable would be the current across the inductor, and the second state variable would be voltage across the capacitor. So may I know how many number of state variables are required? Once you will be converting this electrical circuit into the form of SSM, the 2 number of state variables are required, and precisely they are IL and VC. IL and VC. Yes. So the best most answer is going to be 2. Best most answer is going to be 2. Similarly, let me go into the next question. Let me go into the next question. This problem is more or less same problem probably which we have taken earlier. See what the problem states. Consider a state variable models of the system. Obviously, you can see very well it is nothing but the state equation. What does it mean by the state equation? The state equation relates derivatives of the state variables with the state variables as well as input. So may I know precisely what it is? It's a matrix A which is relating the derivative of the state variable with the state variable itself. It's a matrix B which relates the derivative of the state variables with the input, and that is nothing but the matrix C. That is nothing but the matrix C. Yes. Now, where Y is the output and R is the input. If it is not given, still we can visualize very well because we have been keep discussing along this problem only. The damping ratio zeta and the undamped natural frequency of oscillation omega n has to be calculated to the system. May I know how will you calculate the zeta as well as omega n? See, if you have characteristic equation in your hand, by default the value of zeta as well as the value of omega n can be calculated by comparing the characteristic equation which I would retrieve from this problem with the standard characteristic equation of the second order system. That's it. How the characteristic equation would be calculated? How the characteristic equation would be calculated? Tell me. How the characteristic equation would be calculated? The characteristic equation is being defined as Si minus of A. The determinant of it gets compared with 0. You can see very well, it's the order of 2. So obviously you will take its determinant, which becomes s minus of 0, that's s minus of 1 plus of alpha s plus of 2 beta is equals to 0, agreed? So here goes s square 2 times of beta into s plus of alpha is equals to 0. It's a form of the characteristic equation retrieved from this given problem, And now if I compare this equation with a standard form of the second order system, where it is s square 2 zeta omega ns plus of omega n square is equals to 0. So we start comparing from the omega n square onwards. We have seen earlier. So omega n square is equals to of alpha. So the omega n is precisely root over of alpha. Yes, and similarly 2 zeta times of omega n, 2 zeta times of omega n is known already, which is nothing but root over of alpha, is equals to of 2 beta. Here the 2 and 2 goes off, and here I get to know the value of zeta, which is equals to of beta divided by of root over of alpha. May I know which one is the best most answer? The value of zeta is beta divided by root over alpha, and similarly the value of omega n is equals to of alpha. So probably the crux of the control system is already been communicated within our crash course. So if you guys are still having any sort of doubt, you can put it over the Telegram group. And even if you have a plenty number of doubts, sir, as today is the Devraj, if you have any doubt, you can discuss over the Telegram. I would be there. So probably we can have the chat over the Telegram itself. It's a very small doubt, nothing great in it. But still, if you have the doubt, definitely I am here to support you guys. Yes, what I am saying. So now what I am going to do over here. So you can just go ahead, all sort of the probably 23 or 24 number of videos which has been released so far. In each of the videos, I just wanted to give a brief idea about the individual concepts, although I did not go into the detailed analysis. Yes. And end of the day, once any theoretical part was getting over, I tried to connect the each and individual concepts with the few number of problems which have appeared in the GATE examination. So the people who have been understanding the concept of the control system, or the person who have already gone through the concept of the control system, they should watch this video carefully. Definitely you are going to enhance your marks in GATE 2021 and probably in the next year GATE 2022. Yes. Now before ending today's video, what I am going to do over here, I have taken, or I have sought around 3 number of well-designed problems which have already appeared into the GATE examination. So definitely go through those questions also. Those questions would be more than beneficial to all of us. And today would be the last class of the control system. So I would request to each one of you, go through these videos. Hello dear friends, welcome to GATE Academy Global. So before starting today's video, let me give you the brief idea about the today's agenda. In today's video, I am going to take the 3 number of numericals which have appeared in the GATE, obviously in the different years. But all of the 3 problems are very well designed problem. So you are going to learn so many new concepts once you would be going through the each and individual problems. So the first problem you can see over the board, the first problem have come. In GATE Electronics year of 2010, the problem was framed by IIT Guwahati, one of the very well designed problem. The problem is based on the concept of controller, but more or less you had to discuss about the steady state error. That means the first problem has been picked up from the topic called steady state error. So let me write over here. Here I need to discuss about the steady state error. This would be my first question. Yes, once the first question goes off, we would move into the second question, and what it states, the transfer function of a system GSHS, and for a unit step input we need to calculate the settling time. So far we have taken few number of problems where I had to address the problem where the 2% settling time has to be calculated. But this problem is bit different than the problem which we have taken earlier. Why? Because here dominant pole approximation concept has to be used. That is what I am saying. It's again a very well designed problem This problem is based on the concept of dominant pole approximation. Pole approximation. Again, it is a very, very well designed problem. Very, very well designed problem. If we talk about this problem, when it has appeared in electronics year of 2002, and the problem was framed by ISC Bangalore. Once this problem is done, we would move into the next question, and this problem is better designed problem. And here this problem is based on the concept of time response analysis, which has been appeared in GATE Electronics year of 2019, and the problem was designed by IIT Madras. And one of the best thing regarding this problem, so far whenever we discuss or whenever we deal with the second order system, usually we deal with the settling time with a 2% margin, maybe 5% margin, maybe delay time or rise time, but here you need to calculate the time taken by the system to reach the 94% of its steady state value. What does it mean of it? Any of these standard formula would not come into the picture. You had to manually calculate what would be the time taken by the system to reach the 94% of its final value. That is why I have kept this problem as a well designed problem where the formula which you have by hearted would not help you guys. You have to just start from the scratch and go till the last point of the crux. Yes, till this point, nobody should have any doubt as such. So let me focus over the first question. At very beginning, let me read the problem word by word. What is the problem indicates? A unity negative feedback. What does that mean of it? It's a UFB type of system. The value of H of S is simply equals to 1. The feedback factor is nothing but 1 for this problem. The closed loop system has a plant with the transfer function. That means within the closed loop system we have got a plant, and the plant has a transfer function 1 divided by of s square plus 2s plus of 2. Yes. So here the plant have the plant transfer function, I may call it a of s. The plant have the transfer function is equals to of 1 divided by of s square plus of 2 of s plus of 2. Agree? And the controller GC of s. Anyways, so far I have not come across the topic called controller, but still you guys are having a fair idea about the controller. When I was discussing at very beginning about the complete structure of the closed loop system, there it was clearly told the error signal goes to the controller and the output from the controller, which used to be actuating signal, goes to the plant. This is what my plant is. Yes. In the feed forward path, keep in mind, even the controller can be placed in the two different places, either in forward path, either in backward or the reverse path, but here it has been clearly given that the controller has to be used in the forward path. For a unit step input, that means the system is getting excited by a unit step input. So if you want to write, you can write that also. R of s has been precisely given as 1 upon s in this problem. Nobody should have any doubt as such. The transfer function of the controller that gives the minimum steady state error. That means you need to find the value of GCS such that the value of ESS must be minimum. Is that part clear? Anyways, before going into the detailed analysis of this problem, let me figure it out how they look like in the block diagram format. So this is one thing is quite clear. It is a standard negative feedback system where the value of H of S is 1. So what I would do, let me take few number of blocks first. It is my first block. It is my second block. And similarly towards the feedback side also we will be having H of S. So now what happens, see, try to understand in this way. The error signal goes to the controller, which we have seen earlier. If any of us have any sort of doubt, you can refer my previous videos. The output from the controller used to be actuating signal, which goes to the controlled process, and controlled process itself is called plant. And the output from the plant becomes C of S. And from the output, the feedback has been brought in, and here it gets processed with the H of S, and again it goes to a summer circuit. So that is happening over here. So here goes sort of this. Just a minute. It would go towards upside. And here the circle would come. sort of this. Agreed? Everybody should have the clear-cut idea regarding this feature, And here goes my input. Here goes my input, yes. Input would be something like this. Input would be something like this. Till this point, nobody should have any doubt as such. Agreed? So that is what I am saying again and again. Here goes your controller. The input error signal goes to the controller, which is nothing but ES, error signal. In Laplace domain, you can call it E, capital E of S. Capital E of S. Yes. And the output from the controller used to be the actuating signal. In Laplace domain, I may call it AC of S. AC of S. Goes to the plant or the control process. What it is? The control process or the plant is nothing but 1 divided by of S square 2S plus of 2. Here comes my controlled response or the output in Laplace domain C of S, and similarly here comes my reference input in Laplace domain R of S. Positive, negative. Being a standard UFB system, it has been clearly known, it would be simply H of S is equals to 1. H of S is equals to 1. Now, you must have a clear-cut idea that the R of S, at least in this problem, is being a unit step input. That means the R of S is precisely going to be 1 upon S. R of S precisely going to be 1 upon S. Tell me, whenever we calculate the steady state error, what used to be my approach? Whenever I calculate the steady state error, ESS, when the input is a unit step input, what used to be the result? The result used to be 1 divided by of 1 plus Kp. May I know what used to be the Kp? The Kp used to be limit S tends to 0 of the G total into H of S, where the H of S is simply equals to of 1. Simply equals to of 1. So what I would do? I would keep the G of S such that this factor would be maximum. If this factor is maximum, which is coming towards the denominator side, definitely this factor would become 0 or minimum, and that is what my basic intention is. That is what my basic intention is. So may I know what is going to be the GS? The GS is going to be the cumulative component of, just a minute, is the cumulative component of, let me mark it down, the cumulative component of GCS as well as 1 divided by of S square plus of 2S plus of 2. Anyways, what you had to do, manually you had to feed the each and individual data over the GCS. First you will feed S plus 1 divided by of S plus 2, then you will feed S plus 2 divided by of S plus 1, then you will feed the C as well as D, and end of the day you had to calculate where the steady state error would be minimal. Just try to figure it out. One important thing, probably I do not know how far you could understand. It is a type 0 system. It is a type 0 system. Why it's a type 0 system? You can see the open loop pole has not been kept over the origin. Yes. If GCS is a system which introduces an additional pole at origin, then what it becomes? It becomes a type 1 system or type 2 system or type 3 system, depending how many number of open loop poles are getting introduced along with this plant. So I would expect the GCS would raise the type of the system of a complete block G of S. What happens? We have seen or we have studied already, whenever the type of the system increases, the steady state error goes down. Like in case of type 0, when the input is unit step and the type is a type 0 system, we know that steady state error is a constant value, neither 0 is nor infinity. But if you have been succeed for the same input, and if you have raised the type of the system from greater than type 0 system, what will happen? Definitely ESS would go to the minimalist value, and that is nothing but 0. So what I would ask from each one of you, select the value of GCS in such a way that the complete GS, now the type gets increased to 1, 2 or 3. It should not be 0. If it becomes 1, 2 or 3, by default the ESS would become 0. Agreed what I am saying? So what is happening over here? If you will feed S plus 1 divided by of S plus 2 in place of GCS, what would happen? Initially it was a type 0 system, but no introduction of the open loop poll has been taken place. At origin, that means is still the GS, this is what my GS, that means is still my GS would be a type 0 system, and hence obviously the error may change. I am not saying the error would not change, but the error would not become a minimalistic. And now if you take S plus 2 divided by of S plus 1 in place of GCS, is still the G of S remains a type 0 system. And similarly, if you take this, still it remains type 0 system. But end of the day, once you feed GCS as equals to, let's take its LCM. The LCM is going to be simply S. The S would come towards the left hand side. It would become 2 plus of 3S put together. It would become 4S plus of 2 divided by of S. And now you can see very well, once the GCS is being placed as a 4S plus 2 divided by of S, what would happen? It would get multiplied with the 1 upon S square plus 2S plus 2. And now the type of the system has been raised to type 1 system. And if the G of S is a type 1 system, one thing is quite sure. What it is, sir? Now the steady state error would become 0. That is what I am saying. Such a well planned problem it was. Deliberately they have given the 4 different types of the options, such that you people may get afraid how to deal with this sort of problem. So one thing is quite sure. You had to feed, or you had to select the value of GS in such a way that the type of the GS must increase from 0 to maybe 1, 2 or 3. So obviously you can see out of 4 number of problems, 3 number of problems was not able to convert the G of S to the order of, degree, so type of 1, but the D had done it. D had done it. So obviously what's going to be the best most answer? The best most answer is going to be option D. Nobody should have any doubt as such. Agreed? I would repeat this problem once again. Here the 2 new term have come into the picture. First is controller and second is nothing but the plant. The person who have gone through my earlier videos, they know I call it control process. The input to the control process comes from the controller, and the output from the controller is also called the actuating signal, or you can say the input to the controller used to be actuating signal, whereas the input to the controller used to be an error signal in standard negative feedback system. So this was a complete structure. This was a complete structure. If you guys are stuck in anywhere, just do one thing, just go back to the complete video and try to understand what sir was wanted to communicate. So the best most answer is going to be option D. Nobody should have any doubt as such. Yes. In the same sequence, let me take the second question. Probably this question may not be properly visible to all of us, but still focus on this problem. See, let me focus on this problem. First read the problem word by word, and thereafter we'll try to conclude few of the important outcome from this problem. Let's see what the problem states. See, the transfer function of a system GS is equals to of 100 divided by of S plus 1, S plus 100. So let me write down the transfer function of the system, which has been written by G of S is equals to of 100 divided by of S plus 1 divided by of S plus 100. S plus 100, yes, for a unit step input to the system. That means now this system is getting excited by a unit step input. For the better understanding, let me do one thing. Let me take its equivalent block diagram. So this is a block. The transfer function of this block has been clearly given as 100 divided by of S plus 1 into S plus 100. S plus 100, it's a order 2 system. You can see very well it is a order 2 system. How we got to know it's order 2 system? Because the number of poles which are getting involved with this system is nothing but 2. Now what happens? This system is getting excited. This system is getting excited with a unit step input. That means the input which is getting applied to this system is simply going to be u of t, and in Laplace domain it becomes 1 upon s. 1 upon s. So may I know what would be the output? The output would be just multiplication of the input as well as the transfer function in the Laplace domain. So the output becomes 1 upon s, which gets multiplied with the 100 divided by of s plus 1, and which gets multiplied with the s plus 100. So nobody should have any doubt as such. So this becomes your output. 1 upon s gets multiplied with the 100 divided by of s plus 1 into s plus 100. Yes. And now for a unit step input, the system approximately settling time for the 2% criterion is. Anyways, why the word approximation has been used? Anyways, this problem is a core problem of dominant pole approximation. Everybody should write on your copy. Everybody should write on your copy. Here it's a concept of dominant pole approximation. Dominant pole approximation. Let's see what it is. Dominant pole dominant pole approximation. The concept which we would be using is going to be dominant pole approximation. See, when the concept of the dominant pole approximation is used, the concept of the dominant pole approximation is used if the poles which has been kept towards the left hand side of the S plane, they have been very far distinctly placed. You can see very well the first pole which has been placed, they have been placed at -1, and the second pole which has been placed, it has been placed at -100, or that means they have been placed very far away. If I would like to draw its pole zero diagram, for that I need to take a S plane. So I have taken a S plane. May I know what used to be the imaginary as well as real axis of the S plane? The real axis used to be the sigma axis. So obviously the real axis has been dedicated towards the sigma axis, and similarly the imaginary axis is being dedicated towards the j omega axis. It becomes your S plane. It becomes your S plane. S plane. And now you can see very well how many number of poles you had. The two number of poles you had. The first pole is being kept at -1, and the second pole was being kept at -100. Was being kept at a -100. Anyways, I am not going into the great detail why the concept of the dominant pole is being used, but still you guys should have a very clear idea. If, write down, if poles are far located, as you can see over here, if the poles are far located, then response in time domain, has impact from the pole which is dominant, the pole which is dominant. What does it mean of it dominant? That means the pole which are kept very right hand side of the S plane. So you can see very well, that means this -1 is gonna be a dominant pole. This -1 is gonna be a dominant pole. So in future, as the -100 has been kept very far away from the -1, so you can neglect this -100. So we can neglect this -100. Again, because the -100 would not have any huge impact over the time response over the output, and hence -100 would be dropped. But while dropping -100, one thing must be in my mind. May I know what is that? Keep in mind, first I would arrange the given transfer function into the standard form. What used to be the standard form? So standard form used to be 100 divided by of 1 plus s, and thereafter what would happen? Now here the 100 would be taken common out, so here it becomes 1 plus of s divided by 100. The 100 goes out as a common factor, 100 and 100 goes out. So here it becomes 1 divided by of 1 plus s into 1 plus s divided by of 100. Which one has to be dropped? Non-dominant pole can be dropped, because that would not have major impact over the output response. So 1 plus s divided by 100 has been dropped, or here the new transfer function which comes in my hand is simply going to be 1 divided by of s plus 1. Why we do so? See, if you are dropping any of the non-dominant pole, your steady state value as well as DC frequency, magnitude, or the gain should not get changed. That is why what I did, first I converted the problem into the standard form, and then only I dropped the non-dominant pole. When this concept is true, only and only if the dominant pole and non-dominant pole has been kept a very, very large distance apart. Otherwise, if it is -1 and -2, see, -1 and -2 are comparable. That means the impact in time domain would have the impact from the -1's pole as well as -2's pole. In that case, you can't take that approximation. I would repeat once again, I am not going into the great detailed analysis regarding the dominant pole approximation, from where the dominant pole approximation have come, but just understand in this way, whenever you deal with a higher order system, whereas few of the poles have been kept very far away from the pole which has been kept towards the right hand side, so what you can do, you can just neglect them, because their impact over the time domain would not be that dominant. But still, you cannot just drop s plus 100. First you had to convert this transfer function into the standard form of the transfer function, which I did, and now you can drop a non-dominant pole which was kept at a -100. So here the system which was approximated, this system can be easily approximated as 1 divided by of s plus 1. Till this point nobody should have any doubt. That means this system has been approximated by 1 divided by of s plus 1, and if this system has been approximated by 1 divided by of s plus 1, what does that mean of it? That means the time constant which this system carries is simply equals to of 1, and now I need to get the time taken by the system to reach the steady state value taking the error of 2%. What does it mean of it? Simply it is 4 times of tau. 4 times of tau, the 4 gets multiplied with 1, and here it becomes 4 seconds. 4 seconds. That is what I am saying. Now the people may ask why the concept of the dominant pole is so important. See, concept of the dominant pole becomes very important if you are dealing with a higher order system. See, in higher order system, if you are dealing with a problem which has a higher order system, definitely it becomes a very difficult task to handle. So what you can do? A pole which has been kept towards the very left hand side, you can just push them out, such that the order of the system would start decreasing, and as the order of the system has start decreasing, you would be benefited. And you can see very well, initially the calculation with such a heavy system was not that easy, but once one of the pole got dropped, it became very easy to deal with. Yes, so only I would recommend to each one of you, whenever we are using the concept of the dominant pole, one thing should be in our mind, and that is nothing but I would be dropping a non-dominant pole, provided it must be a very far away from the dominant pole. That's the first thing. Secondly, first I would convert into the standard format, then only I would drop the non-dominant pole. Non-dominant pole. So till this point nobody should have any doubt as such. So let me do one thing. Let me take few one or more two number of problems. See, here you can have the situation like here you can have 100 divided by of s square, no, not 100. Let me take this as 10 divided by of s square plus of 2 of s plus of 100, and let's take here goes s minus of maybe 100, s minus of 100. Yes, no, do one thing, let me change a bit here, change this 100 to 2, this 100 to 2. Yes, 2. And again the dominant pole concept can be used. Why the dominant pole concept can be used? Here the pole has been kept at -1 plus minus j, whereas here the pole has been kept at -100. Obviously you can see its real part which is at -1, and you can see its real part which is at -100. Obviously in future I can drop s plus 100, whereas I can keep as it is. But whenever you do so, first you had to standardize your given transfer function. May I know what would be your standardization? See, first if 2 is there, the 2 would also be here. So here it becomes 2 divided by of s square plus of 2s plus of 2 plus of 2. Agreed what I am saying? Here the 5 is a multiplier factor, definitely would be taken out, and here from denominator 100 has to be taken out. 100 has to be taken out, so the factor which would be left out would be simply equals to of 1 plus of s divided by of 100. And now that depends which factor would get dropped. If this has been kept towards the very left hand side, this factor completely would get dropped. No, nobody should have any doubt as such. Nobody should straight away drop 10 divided by s square plus 2s plus 2 if it is kept towards very left hand side. No, nobody should do that. So here it becomes, sorry, not this one. This drops down. This drops down. So the equivalent dominant pole is gonna be 5 divided by 100, which is 1 divided by 20 into 2 divided by of s square plus of 2s plus 2. Now you assume in this way, if this factor would have been, or the roots of this factor would have been at towards the very left hand side, definitely this would have been dropped, but this would have been dropped along with this complete structure, the complete structure. Nobody should have any doubt as such. Agreed? Nobody should have any doubt as such. That is what I am saying. It is a perfect problem of a dominant pole. Perfect problem of a dominant pole. It is a perfect problem of a dominant pole. Yes, here the s plus 100 was kept so far away from the s plus 1 here. Yes, approximation can be used, although it has not been clearly given, but it is a dominant approximation. Dominant approximation. If the time permits, I would also explain from where the concept of the dominant pole have come into the picture, and why the s plus 100, if it is knocked off, is still there is not much change over the time response of the given system if it is excited with a certain unit step input. So you need not to worry about those things. Is that part clear? Till this point nobody should have any doubt as such. Now we will move it to the next problem, and it is a utterly well designed problem, and this problem have come in GATE Electronics year of 2019. The problem was framed by IIT Madras. What the problem indicates, consider a causal second order system. What does it mean by the causal system? That means this transfer function is true only for the t greater than equals to of 0. Second order system, by default it is looking like a second order system because the number of poles which are getting involved with this system is nothing but 2. So obviously it's gonna be a second order system. Now it is getting excited with a unit step input. That means the input which is exciting this system is a unit step input whose Laplace is 1 upon s. As an input, let Cs be the corresponding output. The time taken by the system C2 to reach the 94% of its steady state value, limit t tends to infinity, rounded to the 2 decimal places is. What does it mean of it? First, what I would do, just understand in this way. First, I would make a block. The block has been dedicated towards the second order system, which is nothing but 1 divided by of 1 plus 2s plus of s square, agreed, and 1 upon 2s plus of s square is getting excited by a unit step input, which is also clearly given with this problem, obviously sir. So may I know what would be the response? The response would be 1 upon s, and if you'll see 1 plus 2s plus of s square, you will get to know it is simply s plus 1 to the power of 2, 1 divided by of s into s plus 1 to the power of 2. And I wanted to know how much time the system would take to reach the 94% of its steady state value. Steady state value of what? Steady state value of the response. And the response is known in Laplace domain, which is nothing but C of s. So first let me focus over the steady state value of the response, which is nothing but limit t tends to infinity of C of t, limit t tends to infinity of C of t. In Laplace domain, it becomes limit s tends to 0 of s of C of s, agreed till this point? And now I would like to ask one thing, over this Laplace function, the final value theorem, can it be used or not? Yes, because one pole is kept over the origin, the another pole has been kept towards the left hand side. So obviously we can use the final value theorem. So here it becomes limit s tends to 0, s times of C of s. May I know what is the C of s? The C of s is nothing but 1 upon s plus 1 to the power of 2. And once I will be feeding s is equals to 0, the result which I get, it's simply 1. That means the steady state value of the response, or the response when the t tends to infinity, is simply equals to of 1. It's simply equals to of 1. Nobody should have any doubt as such. Till this point, nobody should have any doubt as such. So obviously this is what the response when the t tends to infinity, or I can say it's a steady state response for this given problem. Till this point nobody should have any doubt as such, but now I wanted to know how much time the system would take to reach the 94% of its steady state value. So may I know what does it mean by the 94% of its steady state value? That means I wanted to know the time taken by the system to reach the 94% of its steady state value. It is going to be 94% of the steady state value, which is nothing but 1. The 94% of 1 is nothing but 0.94. How much time it would take? 0.94. And now obviously we had to analyze in the time domain. I have not been left out with any other alternate. So what I would do, I would take a Laplace inverse of C of s. Anyways, for taking the Laplace inverse of C of s, first we need to take its partial fraction. Once the partial fraction is done, and thereafter I would take the Laplace inverse of the each and individual component. So if I would take the partial fraction of this, so the partial fraction is simply gonna be, probably you guys are well aware how the partial fraction is being calculated. It becomes a divided by of s plus of b divided by of s plus 1 plus of c divided by of s plus 1 to the power of 2. So this is what the partial fraction of the given response, which is nothing but C of s. And thereafter what I would do, I would take its Laplace inverse. Anyways, at very beginning, first let me focus over the a has been got to be 1, b has been got to be minus 1, and c has been got to be plus 1. I have calculated it has got the two different methods through which the value of A, B and C can be calculated. First is a manual method and the second is a sort trick method. So I would assume you would be able to calculate the value of A, B and C by yourself. So here if I would be taking Laplace inverse, it would become 1, it would become e to the power of minus t, and here, here it is minus t, minus e to the power of minus t, and here it was plus, you had to take the Laplace inverse of 1 divided by of s plus 1 to the power of 2. Anyways, when the square comes towards the denominator only if the differentiation takes place in the Laplace domain. When the differentiation takes place in the Laplace domain, that takes place only if the t gets multiplied. So what I would do, let me figure it out, how would be the structure of t times of e to the power of minus t. The Laplace of e to the power of minus t would be 1 divided by of s plus 1, and because of t there would be a differentiation. If I take a differentiation of 1 upon 1 plus s in Laplace domain, what becomes the output? So here at denominator it would simply become 1 plus of s to the power of 2, and at denominator it would be simply 1 plus s, and there the differentiation takes place with 1, that becomes 0, and next it's gonna be 1 and the differentiation of the denominator which is 1 plus s, which is simply equals to of 1, put together here it becomes minus 1 divided by of 1 plus s square. Yes, so put together I can say one thing, here it becomes 1 minus of e to the power of minus t plus of t times here it becomes minus t times of e to the power of minus t times of e to the power of minus t. Yes, and here goes your response c of t. Now what you had to do, what you had to do, how much time has been taken by the system to reach the 94% of its final value. So what you would do, you start feeding the manually each and individual data. First you would feed t is equals to 4.5, then 3.89, 2.8 and 5.25, and you will try to understand how much time has been, or when the output becomes the 0.94. So you will get to know the output becomes 0.94 precisely. Output becomes 0.94 precisely when the time the time was nothing but 4.5. So that means the system has been taken 4.5 seconds to reach its final value. So till this point nobody should have any doubt. So this was 3 well designed problem. We will meet with the next video. Thank you very much.